Scripting is a powerful tool that allows you to interact directly with your data. This kind of programming can seem intimidating at first, but if you want to create new labels based on calculations or define multi-parameter hit criteria, you'll need to modify some of the existing example scripts. Even if you have no programming experience, editing simple scripts will be relatively straightforward. We'll begin by curating the 384 well luminescence data we've been working with. This will also give us a chance to review some earlier topics, so this section will combine both review and scripting. To make sure we're starting with clean data, let's re-import it from the original raw files. We should still have the parsing definition for this plate set, so all we need to do is select that definition and use bulk import to recreate the data. Select your parsing definition, then the bulk button. Then navigate to your source data. Then finally select your destination folder and overwrite the old data. Now go back to the View pane and make sure the plate state is clean. Right-click on the file and open the .kd file. Notice that it does not contain any of the additional values we added in previous examples. Tip: when working with newly re-imported files after using older versions, you may need to clear the cache or click away from the current plate and back again to refresh the view. Now let's create a new configuration file. Go to the Settings tab and manually clear the well definitions. Then click Save As and create a new configuration file to store your global well definitions. Return to the View pane and define some well types. Mark the control wells. Define the neutral wells. In this experiment, we have border wells affected by edge effects, so we'll mark all the border wells as ignored. Do this on the top, bottom, and sides. Since we originally included some controls and neutrals in borders, the Ignore designation will now overwrite these as Ignore. Watch how the summary changes as we do this. Next, click through your plates and look for other artifacts. We see one plate that shows an unusual pattern on half of the wells. In this experiment, no compounds were added to that section. It is likely that the compound solvent itself, DMSO, affects the background signal. Because this may throw off our calculations, we'll want to dismiss these wells. However, we can't designate them as Ignore, because that is a configuration designation and will affect all of our plates. We'll mark the region as an artifact to keep it specific to this plate. As you do this, watch how the values update in the summary area. Finally, we'll want to normalize the folder for this example. Remember, first make sure the correct label is selected, and then proceed to normalize the folder.